Tractors as far as the eye can see. Le Mans, France, is home to one of the most modern tractor factories in the world. This is where a German agricultural machinery company also builds an especially energy-efficient model, the Axion 960 CEMOS. Its engine delivers up to 445 horsepower, but consumes up to 20% less fuel. Assembling a tractor is much like assembling a car, just on a much larger scale.
I was impressed when I first started here. I used to work in the automotive industry where everything is much smaller.
Modern robots are operating here. For example, in this 12-meter high and 24-meter long high rack warehouse.
Everything's fully automated. 3 robots prepare about 2,000 trays per hour.
In a facility with 100,000 square meters of floor space, assembly teams build tractors without interruption. Every day, some 60 tractors traverse the 500-meter-long main production line.
We can work much faster here and build more tractors in sync.
Every unit goes on the test stand, including acceleration, braking, or load testing. In the factory, on the road, and in the field, every tractor component is inspected.
The wheels are moving, and I can lead the steering wheel, and the system is autonomous.
In 2021, agricultural journalists honored the Axion 960 CEMOS with the International Sustainable Tractor of the Year award. The tractor is extraordinarily energy efficient. The German agricultural machinery manufacturer Claas operates 2 factories in East Westphalia. The main factory in Hasewinkel primarily builds combines and forage harvesters, while the factory in Paderborn produces major components for some of the agricultural machinery manufacturers' tractor model series. For example, the tire pressure control system. It can raise the pressure in the tires of all 4 wheels of the tractor from 0.8 to 2 bar in just 2.5 minutes. The adjustable tire pressure protects the soil and improves traction. This tire pressure control system is also installed in the Axion 960 CEMOS, which experts consider to be especially energy efficient. This tractor's engine delivers up to 445 horsepower and consumes up to 20% less diesel fuel. It weighs over 13 metric tons. It's 5.74 meters long, 3.42 meters high, and has a wheelbase of 3.15 meters. These tractors are in operation in 80 countries. The German agricultural machinery manufacturer's tractors are assembled in Le Mans, France. Since Claas acquired the factory from Renault in 2003, it has invested more than 80 million euros to modernize and expand it. Today, it's one of the most modern factories in the world. High-tech components from Germany arrive on site. Some of them are needed for the tractors of the Axion model series. The engines come from various suppliers and are combined here with transmissions and axles from Germany to form drivetrains. The base unit of the tractor, the drivetrain, includes the engine, transmission, and front and rear axles. The factory in Le Mans assembles 5 tractor model series in various equipment configurations. This also includes the Axion 960 CEMOS, in the wheeled version and as a half-track. Everything runs automatically here. One after another, exactly the right components for the specified tractor model always arrive at the production line. Altogether, the assembly of the drivetrain requires several hundred threaded fasteners. A 3.5 metric ton load suspended in midair. Every 9 minutes, the mechanics assemble a new drivetrain. It takes precise work and extremely high concentration.
I make sure all the bolted connections are tight. Otherwise, parts could get loose and that would be a big problem.
Displays show the assembly personnel all the required work steps, which means they always know what to do next, and that prevents errors. In this work step, the two final drive elements with the brake discs are mounted to the rear axle of the 3.5 meter long drivetrain. The mechanics use 10 grade, 10.9 stainless steel bolts here. These bolts are especially strong. Now, the front axle is mounted to the tractor's drivetrain. The front axle of the Axion 960 CEMOS weighs more than 1.5 metric tons, which means it can handle both heavy front-mounted implements and twin wheels. This is then followed by the remaining hardware, such as fasteners for cable conduits. Assembling a tractor is much like assembling a car, except that everything is on a much larger scale here.
It takes a lot of force to handle these huge parts. I was really impressed when I started working here. I used to work in the automotive industry where everything is much smaller.
It takes 1 to 2 hours to assemble a drivetrain. Then the chassis, consisting of the engine, transmission, and axles, is readied for the next work step. It's about to get wet. That's why an employee covers the sensitive electronic components. He pays particularly close attention to make sure everything is mounted perfectly. And only then does it proceed to the paint shop. The Le Mans tractor factory is home to one of the most modern paint shops in the world. Now that the chassis has been completely assembled with drivetrain and axles, it's coated with primer and paint. The process is carried out in multiple stages: cleaning, degreasing, drying, and coating. Most of these work steps are performed by robots. This thorough cleaning is absolutely essential. The chassis must be completely free of contamination. Otherwise, the paint will not adhere. All salts were removed from the water beforehand. They too would impair the adhesion of the coating. The chassis are dried in special booths at a temperature of 95 degrees Celsius. Only after the last drop of water disappears can they proceed to the next step. Next, employees meticulously mask all sensitive parts and openings.
This is what we use to protect sensitive areas during the coating operation. These barcodes, which ensure the traceability of the parts, also provide protection. We cover the turbocharger with this tape, otherwise it might get blocked by coating residues, which would be pretty annoying. We use these yellow plastic plugs to protect various threads, where screws will be inserted later on. And it's the same story here. If any paint gets in these holes, eventually someone will have to take a lot of time to clean them out. And this is how we cover moving engine parts. Here too, we have to do a really good job. Otherwise, they could have problems in production later on.
Everything is sealed off. Now, the assembly will be primed and coated. Depending on the requirements, paint robots spray between 2 and 4 liters of paint for a 1 millimeter thick coating. In the process, depending on the tractor model, they can call up 80 different coating programs. Paint shop technicians then inspect all the surfaces that the robots have sprayed and rework them wherever necessary. Just 6 minutes later, the coating operation is complete and immediately followed by drying at 80 degrees Celsius. This step optimizes the adhesion of primer and coating to the components. Now, the protective masking is removed and the finished painted chassis are automatically returned to the ground floor. But before the tractor base unit goes to the main production line, employees still have to mount the implement linkages on the front and rear of the assembly. Later on, farmers can attach and hang an extremely wide range of implements on them, such as mowers, disc harrows, and plows. The Axion 960 is considered to be extraordinarily efficient thanks to the CEMOS optimization system. It helps the driver adapt tractor and soil cultivation implements to the operating conditions. That reduces fuel consumption by up to 20%. The adjustable tire pressure protects the soil and improves traction. And the tracked running gear reduces ground pressure by an additional 50%. Back in the factory. On driverless transport systems, or DTS for short, complete tractors are now assembled on the chassis with drivetrain and axles. Under computer control, the driverless transport systems extend to the exact length required for the respective tractor model. From this point on, the chassis ride them piggyback throughout the main production line until the fully assembled tractors finally receive wheels of their own. Each DTS can carry up to 20 tons. Thanks to an in-house navigation system, every DTS always knows exactly where to go. On the main production line, the tractors are now assembled in 36 work steps. The main production line is the heart of the tractor factory in Le Mans. Here, altogether, 100 mechanics install several hundred components simultaneously. Hydraulic lines, brake hoses, the fuel supply system, cooling lines, and conduits for electronic cables. With 1,900 Newton-meters of torque, this tractor is a genuine workhorse. Its tire pressure control system automatically adjusts the air pressure in the tires to protect the subsoil and save fuel. Its fuel tank holds 640 liters. It can reach speeds of just over 50 kilometers per hour, also satellite controlled, and it costs up to 366,000 euros, depending on the equipment configuration. These employees are attaching tubing and hose systems, through which the hydraulic oils for steering, brakes, and implement control will flow later on. Several hundred meters of tubing, cable, and hoses are installed in each tractor. Whether for steering, transmission, fuel injection, or hydraulic system, all functional areas in the tractor today are controlled electronically. The connecting pieces that this mechanic is installing, for example, will give the driver in the cab precise and sensitive control over the tractor's implements. The wiring harnesses being installed here will enable controllers, components, and implements to exchange data at lightning speed with the control panel in the driver's cab. The Le Mans Tractor Factory has a huge warehouse for large and small parts. Every day, some 80 trucks deliver all of the components required for the tractor assembly operation just in time, depending on which models have just been ordered and are being built. A database keeps track of everything at all times. Replenishment orders are placed for any missing parts automatically, which ensures that production runs smoothly, without waiting periods. Around 2,000 parts arrive at the warehouse daily from other factories and from suppliers throughout Europe. And just as many leave it en route to the production floor. The key to it all is this automated high-rack storage facility with hundreds of thousands of small hardware components. It's comprised of 6 rack sections, each of which are 12 meters high and 24 meters long. Altogether, there are 20,000 storage locations here. The fully automated high-rack warehouse always supplies exactly the right parts to the production line. And it also has another benefit.
This lets us optimize the available space. We need less floor space and can make optimal use of the height of the building. And it also takes less personnel.
3 robot systems prepare up to 38,000 trays daily and supply them to a central distribution point in the factory. From here, the components are delivered to the exact location in production where they're needed right at the moment. The factory-wide database ensures that the drivers always know which workplace to take the parts to. Many small hardware parts end up at Aurélien Lemaitre's workplace. He then distributes them to his colleagues on the main production line. Display screens tell him which screws and washers he has to portion out in which quantities. He fills hundreds of plastic cups every day. No tractor would ever be finished without him.
It's so much more practical because you can't make a mistake. You never have to worry that something might be missing.
He packs several thousand parts per shift, 5 days a week. To keep the job from becoming too monotonous, employees change stations every few days. Among other things, the screws and washers are needed to assemble and fasten the tractor's exhaust system. An essential part of the exhaust system, the highly complex exhaust gas aftertreatment system, comprises several components. Along with the AdBlue tank, which will be added on later, its principal elements include the particle filter and the catalytic converter. Eventually, the AdBlue urea solution will be injected into the hot exhaust gases. The nitrogen oxides generated during combustion will be converted to nitrogen and water. Adding AdBlue and using a particular filter to filter out soot reduces the environmental impact of modern diesel engines. These hoses are secured with metal clamps to ensure that they don't come loose under pressure during operation. Next, the windshield wiper fluid tank is mounted on the tractors. Together with the windshield wipers, it will give the driver a clear view of the field, even under very dusty conditions. After barely 1 hour on the main production line, the first part of the exhaust system and other add-on parts are already installed. The last connections are tightened. In the next work step, the mechanics connect all the wiring harnesses with their waterproof connectors. Several hundred meters of cable and hoses are installed in each tractor. Color coding helps the mechanics install the cables and hoses. Each color symbolizes a particular component or a special connection. And when the work is finished, computers also verify every connection. This minimizes errors. The driverless transport systems can be raised to exactly the right working height. This facilitates installation, is easier on the back, reduces stress, and minimizes the risk of error. Finally, the mechanics mount the huge radiator assembly to the front of the tractor's engine. Hoists help move the parts, some of which weigh several hundred kilograms, precisely to their intended location. All that remains for the installation teams to do now is tighten the bolts and connect the lines. After about 2 hours, the installation of the complex cooling and exhaust systems is complete. Most of the work needed to get the tractor running is now done, even though it doesn't look much like a tractor yet. In Germany alone, some 17 million hectares are used for farming and forestry. That represents about half of the total area of the country. Bavaria holds first place, followed by Lower Saxony and Mecklenburg-Vorpommern. There are around 270,000 farms in Germany, employing a total of about 1 million people. A modern tractor's workstation looks almost like the cockpit of an airplane, fully air-conditioned and, on request, practically autonomous. Back at the tractor factory in Le Mans, France. Now, the driver's cab will be installed on the chassis with drivetrain and axles. The cabs are delivered to the main production line fully assembled. This one will soon be married to the rest of the tractor. Production celebrates about 60 marriages per day here. Each cab is made of steel, glass, and more than 1,000 individual parts, such as the instrument panel, steering wheel, seat, roof, and fenders. In this work step, safety plays a major role. These cabs weigh between 500 and 1.2 tons. During the marriage with the chassis, this massive weight sometimes swings back and forth. That's why team leader Baptiste Jasson makes sure that the employees on his team take special precautions.
We build many different versions here, so my colleagues have to pay attention. For example, to make sure that this little red ring is seated correctly. Otherwise, fluid can leak out later on. They also have to pay attention for their own safety. When you climb back down from the cab, you have to be extremely careful not to trip or get your arm caught. After that, it's all about connecting everything up correctly. We use torque wrenches to do this. We don't need anything else.
During installation, the key is to drive the more than 15-centimeter long bolts straight into the threaded holes. Skewing even just one of the 12 bolts will prevent the team from joining the cab to the chassis securely. Success. Within just 7 minutes, the mechanics now fasten all 12 bolts of the cab, hook up 10 hydraulic lines, and connect 7 connectors for the onboard electronic system. This work step is important because all the connectors, hydraulic lines, and electronic data cables converge in the driver's cab. Later on, they will enable the driver to maintain full control over the multi-ton tractor out in the field. The manufacturing process, comprising 36 steps in all, continues. Now it's time for the tanks. Depending on the model, they hold between 150 and 850 liters of diesel fuel. The Axion 960 CEMOS consumes about 45 liters per hour. To operate for the same amount of time, comparable tractors need up to 5 liters more. For some tractor models, the empty diesel tank can weigh nearly 130 kilograms. Too heavy for an employee to lift, so hydraulic equipment is used. The main production line is more than 460 meters long. Almost half of the factory's 800 employees work here, ensuring that more than 10,000 tractors roll off the line every year. At the next station, the tractor is filled up with all the liquids that it needs. Along with diesel fuel, the basic fluids include AdBlue, engine and transmission oil, engine coolant and refrigerant for the air conditioner, as well as hydraulic oils, brake fluid, and windshield washer fluid. It only takes a few minutes to fill any tractor with all its fluids, and only then can the engine be started up for the first time. The engine still has no enclosure, so this shield protects the employees in case any parts come loose during the very first run-in. Now, for the moment of truth. It runs. The assembly team's work has paid off. Another tractor will soon be ready to do its job in the field. But first, it must undergo a series of mechanical and digital checks to verify that all systems operate flawlessly. The engineers are satisfied. Everything works perfectly. Now that the engine has been successfully started up and all the systems have passed their tests, employees install additional components, such as the trailer coupling. Next, each tractor's engine receives its hood, with the appropriate model designation. Depending on the size of the model, the hood can weigh over 50 kilograms. This is also the case for the hood on the Axion 960 CEMOS. That's why a machine does the heavy lifting here. Tractors get decked out like this one after another at regular intervals, measured in just minutes, up to 60 times per day. The hood and its mounting hardware are fastened to the chassis with several bolts. Now, all that's missing are the mud guards for the wheels and the wheels themselves. Then the tractor assembly will be complete. Altogether, the factory in Le Mans takes 28 to 50 hours to completely assemble a tractor and have it ready for delivery. Since 2003, the German agricultural machinery manufacturer has invested over 80 million euros in the modernization and digitalization of its tractor factory in Le Mans. That modernization makes it possible to build ever more complex and individually configured tractors. At the last station of the main assembly line, the tractor gets its wheels. On the Axion 960, the standard rear wheels are 2.15 meters in diameter. The front wheels are up to 1.7 meters in diameter. Mobile robots take the wheels from the warehouse and deliver them to each tractor automatically. To fit the wheels perfectly onto the suspension, a laser system is used. It shows the mechanic exactly where the wheel belongs, so nothing gets skewed when tightening the fasteners. Using a joystick, the assembly technician guides the wheels up to the tractor. The laser markings help position them precisely on the axles.
The display tells me exactly what to do. Here, for example, I have to tighten 2 bolts on the wheel, here and here. I use the joystick to set the position and either tighten or loosen again. The system also shows me when everything is perfectly in place.
There are hundreds of different tire combinations, depending on the model and the customer's preference. Together with the rims, each of the tractor's wheels weighs between 300 and 1,000 kilograms. Thanks to hydraulic hoists, the assembly team doesn't have to lift the wheels on their own. Instead, they only have to fasten them to the tractor with precision fit accuracy. At any given time, a special pneumatic torque wrench always tightens exactly 2 of the 8 bolts that secure the wheels to the suspension. Now the tractor drives on its own wheels for the first time, off to the final quality control.
This is really great progress. For control purposes, we used to use photos to compare the different wheels. Today, the whole process runs almost automatically, so we can work much faster and more effectively and build multiple tractors in sync.
The last work step in the tractor factory is also one of the most important ones. Every finished machine undergoes a multi-stage quality control inspection before it leaves the plant. On this test stand, inspectors verify that the tractor accelerates rapidly and uniformly and reaches the top speed of up to 50 kilometers per hour. This tractor does exactly what it's supposed to do and can continue on to the next test. This test stand measures braking performance. It's important that the tractor comes to a stop in compliance with standard regulations and slows down smoothly when low brake pressure is applied. The front and back of the tractor is also secured with steel chains to ensure that it cannot break loose from the test stand. The test stand scans each tractor automatically for model, length, and tire diameter, and then uses that data to run the right test sequence for each machine. After about 20 minutes, all of the driving condition simulation tests are complete. Benjamin Bourillon records this tractor in the system as error-free.
everything has to be adjusted with the specification of the tractor, and tractor is much more complicated than a car. So it means that all the parameters in the system are linked with all the options of the tractors. Front wheel side, rear wheel side, weight of the tractor, options. So yes, really, it's really specific between COMA to each tractor coming here in the braking test bench.
After a short test drive through the factory, an engineer verifies that the lifting forces meet required specifications, and whether the linkage can withstand tons of loading under these extreme test conditions. Over 4 tons bear down on the front linkage, and it handles them without any problem. The test simulates extreme forces rarely encountered in the field. As a result, the tractor is always prepared, no matter what happens. It passes this test too. Next comes the electronics and hardware check. Here, the engineer verifies that all lights, pedals, switches, and levers work perfectly. But that's not all. In the final test, another engineer confirms the previous inspector's results. Anything worth doing is worth doing twice. This final test sequence covers a list of 100 checks inside and outside the tractor. The engineer also performs an extremely careful examination of any parts reworked due to non-conformance during previous inspections. The tractor cannot be delivered to the customer until everything is 100% okay here too. On the factory grounds, several hundred finished tractors await their new owners. 75% of the tractors built here in Le Mans are exported to the US and throughout Europe, and even to China, Africa, and Australia. Providing healthy and sustainable food to the greatest possible number of people is a global challenge. Food production and forestry are responsible for up to 12% of all greenhouse gas emissions in the EU. Modern economical agricultural machinery are helping reduce greenhouse gas emissions and to protect the environment. The challenges continue. To develop and build even more efficient tractors, the agricultural machinery manufacturer operates a testing and development center near Le Mans. Here, in the Tranget Test Center, 6 miles west of Le Mans, the engineers conduct endurance tests to obtain important findings regarding all installed parts. This shake test stand simulates the entire service life of a tractor, with nearly 30 tons pushing against the machine at each contact point. The system recreates the extremely broad range of road and field conditions that the average tractor experiences during its more than 10,000 hours of operation. Based on these test results, the engineers determine which parts wear out prematurely or come loose, and can redesign them accordingly. Fabien Lombrisi is Product Evaluation Manager and responsible for making the tractors ever stronger, more effective, and more efficient.
The aim of this test bench is to see very quickly things that we would see in a very long time during real life. So we want to see things happening. This is really the aim.
Because every error they discover here can still be ironed out before it actually occurs during operation out in the field. The errors are instructive for the engineers, enabling them to continuously optimize the tractors.
You have to make it more strengthful, changing the concept how the things are linked together, changing suspension, the stiffness, you have multiple way of improving things. But of course, we are seeing the feedbacks from the test, but we have to explain this to the R&D and engineering, and so after that they can change and they can improve the design.
This is not the only tractor manufacturer's development department. There are similar facilities in Germany and in other locations. They specialize in energy efficiency, the tire pressure control system, or tracked running gear systems, for example. Here in France, the primary focus is on improving the tractor's strength and endurance. And with that in mind, the site has its own tractor test track and its own test field. Today, the engineers are testing the most popular model, along with the largest and most powerful tractor of the Axion model series, with 445 horsepower and tracked running gear. Robin Perlemois is verifying that the GPS-assisted autopilot works perfectly.
Yeah, the GPS can control the tractor, so for example, I just press this button, and now wheels are moving, and I can let the steering wheel, and the system is autonomous. And now I just have to manage the speed. I can accelerate or decelerate, and I can work like that easily.
The autopilot can even turn the tractor around in the field and always maintains the optimum path to work the field. Today, the engineers are also verifying that the two tractors' GPS systems are working in concert with equal precision. They intentionally drive in single file to test whether the transmitted tracks are retraced exactly. And whether automated turns are executed with equal precision. In other tests, the engineers also determine how well the tire pressure control systems work. These systems automatically adapt to the specific ground conditions, reducing fuel consumption and minimizing the stress on the soil. Findings are continuously applied to the development of new models. The goal is to develop more effective, more energy efficient, and more sustainable farm machinery. The tilling and harvesting of agricultural land are time-consuming and costly undertakings. Just a single combine harvester often costs more than 300,000 euros. That's why many farmers today no longer own large modern farming machinery themselves. Instead, they rent them, along with the driver, from so-called contractors. Such contractors bring the appropriate machinery to the fields and take care of all soil preparation, sowing, field maintenance, and harvesting operations. For example, the contractor Agrarservice Sachsen, which specializes in the sowing and harvesting of grains and corn. Today, these men and their machinery are harvesting a farmer's cornfields in Rheinsberg near Dresden, Germany, together with the support of the dealer responsible for this part of Saxony. Contractors offer their full spectrum of services, from tillage to sowing, crop protection and fertilization to harvesting. To that end, they provide an extremely wide range of tractors, combine and forage harvesters, implements and trailers for rental, along with drivers. When the farmer cannot operate his own machines profitably, this is often a less expensive alternative. Contractor Maximilian von Schönberg is one of the best-known agricultural service providers in Saxony. Almost every day, and with genuine conviction, he enjoys driving tractors and other machinery.
From the day I was born, it was clear to me what career I would follow. I grew up with farming, and I've always been fascinated by machinery and technology.
And he's also concerned about rising fuel prices. No wonder, with 20 diesel-guzzling machines continuously in operation throughout the season. That's why every liter of fuel he saves matters to the contractor, so he can avoid having to keep increasing his rental prices.
Sustainability is always a bit of a problem, of course. We could compare it with the supplies we need. In this case, basically the diesel fuel, and we can say that the consumption itself is already lower now than with the previous model. But it's also relative to comparable brands. We use between 5 and 10% less diesel.
That doesn't sound like all that much at first, but with many tractors, it all adds up, saving tens of thousands of euros over the course of a year. And the CO2 emissions are also lower, an important step along the way to achieving the EU goal of becoming climate neutral by 2050. Manuel Lippert, who works for the local dealer, grew up on a farm and has learned to handle agricultural machinery since he was a child.
It's really comfortable, of course. I would even call it luxurious inside a modern tractor. By comparison, the older ones are harder to maintain, something's always dripping somewhere, there's no air conditioning, and the cab never has such nice suspension. So the new tractors are really much better. And it's just more fun. And you also get more done. And afterwards, you don't just collapse into bed at night. It's really fun.
The technical advancement of tractors conserves not only the environment, but also the farmer's patience and time, because the intensity of their work is continuously increasing to satisfy the ever-growing demand for agricultural products.
Basically, farming is my passion. It's hard to make a living from agriculture anymore. But it's great fun, and in the end, farming is what feeds people. Nothing else does. And many people forget that.
At harvest time, the men work every day from early in the morning to late at night. They make sure that we all get fresh, local, and healthy food on our plates whenever we want it. Work, where the technology helps people produce faster, more efficiently, and more sustainably. Modern, efficient tractors make an important contribution to more eco-friendly agriculture. Their high-tech engines and process optimization make these tractors from Le Mans among the world's most efficient. And industry experts also consider the factory that builds them to be one of the most modern of its kind in the world. In a facility with 100,000 square meters of floor space, 800 employees build more than 10,000 tractors per year. Thousands of parts, large and small, countless screws and washers, and a total assembly time of just 28 to 50 hours. And then, another new tractor rolls out of the French tractor factory. Computer-controlled robots and laser technology ensure that wheels weighing as much as a ton or more and measuring up to 2 meters in diameter are correctly mounted to the tractors. A hefty 14 tons, nearly 6 meters long, and up to 445 horsepower. The most powerful tractor produced here is a genuine titan. More than 10,000 tractors leave the factory in Le Mans year after year and operate in some 80 countries the world over.